A charge of 8 millicoulomb, we call it as Q1, which is equal to 8 into 10 to the power minus 3 coulomb, is located at origin. Calculate the work done in taking a small charge, which is equal to Q2 minus 2 into 10 to the power minus 9 coulomb from a point P, which is 0, 0, 3, to a point Q, which is 0, 4, 0, via point R. So the first thing is clear about this question, that this point R doesn't contribute anything for this particular question, because electric field is an example of conservative force field, and it just depends upon the initial and final position and is irrespective of the path which the particle takes during its journey from one point to the another. So the question which we are asked is to calculate the work done. So work done can simply be written as the change in potential energy. So if I write the initial potential energy for the system, so the separation between them initially is 3 centimeter, because it is 0, 0, 3. So d1 is equal to 3 centimeter. We are writing it as 3 by 100 meter. So initial potential can be written as K Q1 Q2 by d1, and the final value can be written as K Q1 Q2 by d2, where d2 is equal to 4 centimeter, which we write it as 4 by 100 meter. Now the next thing which is clear is that it is an example of an attractive force, so potential energy is going to be negative. Since these forces are attractive in nature, so the potential energy is going to be negative. And hence now if we write the formula for work done, that is final minus initial, so we get this equation as K Q1 Q2 by d1 minus K Q2 Q1 Q2 by d2. So if we substitute the value over here, we get it as 1.27 joule. We just have to put the value of Q1, Q2, D1 and D2. So we get the value equivalent to 1.27 joule for this particular question. So with this, we have come to an end for the questions of electrostatics 1. The next portion will be electrostatics 2, and we will deal with much more questions in the next segment.